Hello everyone. In this video, we are going to understand that how we can fit a parabola on given set of data points. So this topic comes under the curve fitting, and we will see what is the meaning of this fitting a parabola by taking a working example. And at the end of the video, we will see the algorithm and the pseudo code and the implementation of this whole method using a C program. Okay, so let's start. So let's first understand what does curve fitting mean. So let's say we are given some set of points in the form of x comma y. Okay, so this is the x-axis and this is y-axis. Okay, and these are the points 1 comma 3, 2 comma 1. Okay, and we have to tell how we can join these given data points. Okay, so one way to join these data point can be something like this one, and there can be some another way to join these data points. Another way can be like we can draw a curve, something like first we join these data points, then let's say we join this data point, and then this, and then this. Okay, and the same way we can join some another way also. Let's take another example. For example, again we are given some data points, and these are the data points that we are given. So let's say we can join them something like this way. Okay, or there can be some another way also, so that we can join these. Okay, so joining these data point means we have to find a relation between these data point. Okay, so there can be many curves which can join these data points which are given to us. The line can join the data point, or there can be a parabola, there can be an exponential curve, and so on. Okay, which can actually fit these data point. So when we say fitting a curve, what does it mean? It means we are actually finding a curve which can actually satisfy these points, or which can relate these data points. So we have to find that curve. Okay, and finding the curve means we have to find the equation of that particular curve. Okay, so for example, if this is the curve which can show the relation between these data point, that means we have to find the equation of this curve. And when we are saying that we have to find the curve, that means we have to find the actually best fitting curve. Okay, so what does best fitting curve means? So actually best fitting curve means that we have to find a curve which can actually minimize the error. So it means, for example, we can draw a curve something like this. Okay, now there can be some another curve also. Okay, so there can be many other curves which can join these data points. So this is the actual data point. Okay, and this line is actually going over these two data points, but this line is not going over this data point. It is somewhat far away from this data point. So this distance is called error. Okay, and the same way, the distance between the actual data point and the actual line, this is again a error. So we have to find a curve which can actually minimize this error. Okay, so the curve should actually touch all the data points as far as possible. Okay, so that curve will be the best fitting curve. Okay, so the main point is we have to minimize the curve. That curve will be the best fitting curve. Okay, and the main objective we can say is we have to find the equation of that particular curve. As I told you that there can be many curves which can fit a particular data point. Okay, in this video we are going to see that how we can fit the parabola curve which can satisfy the given data points. Okay, so when we are saying again that we have to find a curve which can satisfy the data point, that means we have to find the equation of that parabola. So we will be finding a second degree parabola. Okay, so what is the equation of that second degree parabola? So the equation is y equal to ax square plus bx plus c. And just to tell you what is parabola, so parabola in graphical form, it can be something like this way. Okay, or it can be something like this way. Okay, so this is actually a parabola, and this is a second degree parabola, means this is a quadratic equation. Okay, so when we are finding the equation of this parabola, it means we have to actually find these a, b and c. That is, we have to find the value of these a, b, c, these constants. Okay, so actually when we are given in the equation some set of data points, and we have to find the equation of the parabola, that is a, b and c, these constant we have to find. So there are actually various methods to find this constant in the curve. Okay, So there can be like graphical method, method of group averages, method of least square, and method of moments. Okay, so actually we will be using method of least square in this video to find the equation of the parabola. Okay, so here is our question. So the question says we have to find an equation of second degree parabola which fits to the following data. Okay, these data points using the least square method. Okay, and the question can be something asked in that other way also. For example, the question can simply be like find the second degree curve which can fit these data points using the least square method. Okay, so the question may not directly ask for the equation. You have to understand by yourself that the question actually means that you have to find the equation of the curve that it is asking. So in this question, we have to find the equation of the parabola which can actually satisfy these data points. Okay. As we know, the equation of the parabola is y equal to ax square plus bx plus c. Okay. So the first step in solving this question is we have to put the summation on this equation. So let's say this equation is equation number 1. So after applying the summation, we will get summation of y equal to, now a is a constant, so it will come out, and summation of x square plus, when we put summation of bx, b will come out and it will be summation of x. Now c is a constant, so when we apply the summation on this constant, it will become n into c. Now here n is actually number of observations or the number of data points. So how many data points we are given? So this is the one data point, that is 0, 1. This is 0 and this is 1. Same way, this is the another data point. Okay, and this is the next data point and next. So there are total 5 data points. So the value of n is actually 5. So when we put summation on this constant, it will become nc. So actually it means, for example, c is, let's say, 6. Okay, so it means we are adding this 6 5 times. 6 plus 6 plus 6, 6 plus 6. Okay, so it will be 5 times. Okay, so it means we can simply write 6 multiply 5. Okay, so this c is 6 and n is 5. Okay, now second step is we have to multiply this equation by summation of x. Okay, after multiplying this equation 1 by summation of x, we will get summation of x5 equal to a. Now this x square will become summation of x cube. Okay, now summation of x when multiplied with bx, it will become b into x square summation. Okay, and when summation of x is multiplied with this c, it will become actually c summation of x. Okay, so this is the next equation. Now again we will multiply the same first equation by again summation of x square. Okay, so here now we are multiplying it by summation of x square. Okay, so now we will get this equation. So when we multiply this by, you can simply say x square. Okay, and we have to put summation. So it will become x square y, then this will become x4, this will become x cube, and this will become c into summation of x square. Okay, so we have got these 3 equations. So this is equation, let's say 2, this is equation number 3, and this is equation number 4. After we have got these equations, now we have to find the value of this summation actually. Okay, so we have to find the value of this, like you can say summation of y, summation of x square, summation of x, then summation of x cube, summation of xy, and all these summations. Okay, so that we can solve these 3 equations to find the value of a, b, and c, and finally then only we can get the equation of the parabola. Okay, so how we can find the value of these summations? For that I have created this table, and in this table I will be finding the values of this summation. So let's see how. So these are the values of the x, that means these value 0, 1, 2, 3, 4 we have written here. Okay, and these are the values of the y. Okay, this 1, 1.8, 1.3. Okay, so these are the values of the y. Now we have to find the values of the various summation. So here if you see in these 3 equations, we have to find actually all these summations. What summations? We have to find summation of x, summation of y, summation of xy, and so on. So we have to find all these 7 summations. Okay, so total 7 summations will be found out to find the values of this a, b, and c finally. Okay, so first let's see this xy. So xy means x multiply y. Okay. So how we can find the value of this xy? So this 0 multiply 1, it will be 0. Okay. Then 1 multiply 1.8, it will be 1.8. 2 multiply 1.3, so it will be 2.6, and so on. We can multiply. Okay. So I multiply all the xy. Okay. Now I have got all these values of the x multiply y. Okay. Now summation of xy means we have to add all these values 0 to 1.8, 2.6, 7.5 and 25.2. All these values should be added to get the summation of xy. Okay. So if I add them, I will actually get 37.1. Okay. You can add them, you will get 37.1. Now we have got summation of xy. Now next point is we have to find the summation of x square y. Okay. So for that we have to find the various values of the x square y first. Okay. So again x square y means we have to first find the x multiply x, then we have to multiply y. Okay. So if we do this calculation, that is this 0 into 0 into 1, you will get simply 0. Okay. Then 1 multiply 1 into 1.8, it will be simple this one. Then this will be like 2 into 2, 4, 4 into 1.3. So it will be like 5.2 and so on. We can write the other values. So on adding all these values, I will actually get 130.3. Similarly, I will be finding this x square, x cube, x4. Okay. So simply x square is like the square of all these x values. Okay. And after finding those x square values, I can just add them. Similarly, I will be finding x cube and x4. Okay. So I will be directly writing all these values. So I have written all the values and I have found all the summation. Now last summation is summation of x that is remaining. Summation of x simply means just add all these values. So all these values summation, it will be simply 10. Okay. 4, 3, 7, 2 plus 1. Okay. And if I add all these y values, I will actually get 12.9. Okay. So now all the 7 summations we have found out. Okay. So what is the next step? Next step is we have to put the summation value in this. Okay. And we will get the equation in the form of a, b and c. Okay. So let's see how. So here you can see I have written that table again that we have just found. Okay. So all these are the summation values. Now we will put all this summation value in these 3 equations. Okay. So here you can see the summation of y. If we put summation of y is 12.9. So this is 12.9. Then summation of x square, that means this is 30. Okay. So it will be 30a. So you can see we have 30a. Okay. Similarly, b into summation of x. So summation of x is 10. So this is 10b. And similarly, the n into c means what is the value of n? N is 5. Number of observations 5 into c. Okay. So similarly, we can put all these summation values. Okay. And this a, b, these are the like constant that we have to actually find. Or you can say these are the variables for the time being in these equations. The values of a, b and c we have to actually find at the last. Okay. So we have got these 3 equations after putting all these summation values. Okay. So what will be the next step to find all these 3 values? So you can see there are actually a, b and c. You can say 3 values that we have to find. And how many equations we are having? We are having 3 equations. Okay. So according to the Maths theorem, you can say that if we are having 3 equations and we have to find 3 variables value, we can easily find. Okay. So these are the 3 equations that we have to solve to find the values of a, b and c. So we can actually use any method to find this value of a, b and c according to whatever we have studied in our maths classes. Okay. So when I will be implementing this method in our C program, I will be using Gauss elimination method to find the values of a, b and c. So you can see these are actually 3 linear equations, or you can say these are 3 simultaneous linear equations. So Gauss elimination method helps us to find the values of the unknowns of the simultaneous linear equation. So here you can see we have the 3 unknowns a, b and c. Okay. So I have already discussed Gauss elimination method with the working example and its C programming implementation. You can find the link of that video in the description below or in the I button also. Okay. So when I will be telling you the pseudo code of this method, then I will be using Gauss elimination method. But for the timing, let's take some another approach to find the values of a, b and c. So what technique I will use? So let's say this is equation 1, this is equation 2, and this is equation number 3. Okay, so let's take the equation 1 and equation 2, and you can see that I will be actually cancelling out one of the value. Okay, so you have studied like we can just multiply this equation number 1 by 2. Okay, so what will happen by multiplying this equation by 2? This will become 10c. Okay, so this equation 1 and equation 2 we can use, and then this 10c we can cancel out at the last. Okay, so let's see. And this you have, and this method you must have studied in your maths classes. Okay, so I have multiplied this equation number 1 by 2, so we have got this equation, and this is the second equation as such. So here you can see we have got 10c and 10c, so we can just subtract, or we can just change the sign of this second equation, this equation. So after changing the sign, we have got this 10c cancelled, and finally we have got this equation in terms of a and b. Okay, now in the same way we can solve these two equations. Okay, and here also we can multiply this second equation by 3, so that 30c and 30c will be cancelled out. So here we can see I have multiplied this equation by 3. Okay, and we have got this, and this is the third equation as such. Okay, so we just change the sign, 30c cancel out, and we got this equation. Okay, now these are the two equations in terms of a and b, and if we solve these two equations we can get a and b. So these are the two equations. We just solve these two equations by subtracting or by changing the signs, and we got the value of a. So the value of a is 0.55. Now as you know, we can put the value of this a in any of these three equations. Let's say we put the value of a in the equation number 1, so we got this thing, and similarly we can put the equation of a in the equation number 2, this one, so we got this equation. Now we can solve these two equations, and we can easily find the value of b and c. So we got this value of b and c after we solve these equations. So this was just the basic mathematics that you have just studied in your maths classes. So finally we have got values of the unknowns or the constants a, b and c. So last step is we have to find the equation of the parabola. As we know, the equation of the parabola is y equal to ax square plus bx plus c, and we have the value of a, b and c. So after putting the value of a, b and c, we got this equation, y equal to this equation. Okay, so this is the equation of the parabola, which can actually best fit our given set of data points. So I hope you have understood the method. So just to recall, we first wrote the equation of the parabola, that is y equal to ax square plus bx plus c. Then we multiplied the first equation by the summation. Then again we multiplied this equation by the summation of x. And then again we multiplied this equation with the summation of x square. And so we got three equations. Now we have to find the summations which are in these three equations. So for that we created the table, and we found out the various summation values, so that we can put them into these three equations. So after putting the values of the summation, we got these three equations. And finally, we solved these three equations to find the values of the unknowns, that is a, b and c. So we got these values of a, b and c, and then we fit these equations in the equation of the parabola. So we got this equation of the parabola. Now let's see the implementation of this method. So first let's see the algorithm, and then we will see the pseudocode. So first we have to ask the user the number of observation or the number of total data points that he want to enter. So here in our question, we have total n equal to 5 data points. So this is the first data point 0, 1, second is 1, 1.8, and so on. So after asking this n equal to 5, you can say from the user, then we will ask the actual data points. So first we will ask the user the various values of this x, then we will ask the values of the y from the user. Okay. Now after that, we have to find the various summation values. So as we discussed, we have to find all these 7 summation values. Okay. And after finding these summation values, we have to put these summation value in the 3 equation that we obtained. Okay. And to find the values of the a, b and c, we can solve these 3 equations that we have got. Okay. So we can use any method, as I told you. So in programming, I will use the Gauss elimination method. And after we have solved these equations to find the values of the a, b and c, then we have to put these 3 values a, b, c in this equation of the parabola, so that we can get the final equation of the parabola. Okay. So let's assume we have the values of the x and values of the y, okay, from the user, and we have the value of the n. Let's say in this question n will be 5, the total number of observations, okay. Now after that, what is the next task? Next task is we have to find the various summation values, right? Now the question is, where will I store these values of the x and y? That is, what data structure I will use to store these values. So I can simply use two 1D arrays, array having the name x and another array, the array y, and both are having the size as n, okay. So this array is having total 5 elements, 0, 1, 2, 3, 4, and the same the array y, it is having the size 5, okay. So this values will be stored in array y and this value will be stored inside the array x, okay. Now the question is how to find these summation values. So there can be many approaches to find these summation values, okay. So one optimized way to find the summation value is this one. So first I will take the variables to store these summation values. So I have taken 7 variables to store each of these summation values, okay. Now the naming I have used is like as x. So s is telling me that I am finding the sum, and x means that I am finding the summation of this, okay. And x, y, that means I am finding the sum of the y values, okay. So I have written the name as sy. The same way, if I am telling that this is sxy, so sxy is storing this summation value, okay, this summation value sxy, okay, this summation value. So initially all are having the 0 value, right? Now after that I have taken a loop which is actually running from I equal to 0 to less than n. So for n equal to 5, it will run 5 times from 0 to 4. Now as you can see inside this for loop, I am finding these summation values inside this variable, okay. So how I am finding this summation value? So actually what I am doing is, as you can see in this code, first I am adding this thing, okay, this value inside this s of x, okay. Now in the same iteration I am adding the value of this yi. So as you can see, y of I, that means initially y of I, that means 1, okay, for I equal to 0, okay. So I am adding this value also inside the new variable s of y, okay. So this value is added. Now in the same iteration I am adding what, s of I into y of I. So x of I into y of I will be 0 into 1, that is 0, okay. So on the fly, that means on the runtime only, I am finding the multiplication of x of I into y of I. So these values actually I will not store anywhere. The same way I will not store all these value anywhere, okay. I have not created any third array to store these value or the fourth array to store these value. I have only used these two arrays, okay. This you have to take care, okay. I'm not storing any of the value anywhere. I am actually adding all the values in just one loop. So after adding this, now next task is I have to add this value, okay, into the new variable x of x to y. The same way I am adding all the value in their respective variables. Now in the first iteration, the value of x will be 0, this sum, then it will be like having 1, it will be having 0, 0, 0, 0, 0, okay. Now in the next iteration, that is for I equal to 1, what will happen? All the 1th index value of every of the thing will be added. So for I equal to 1, this will be x of 1. So x of 1 is this, okay. So this will be like 0 plus 1 equal to 1. Now x of y will be like, this value will be added. So this will be added, that means total will be 2.8, okay. Now again in this 1th iteration only, I will add this value, okay. So this is like x of I into y of I, okay. So these two value will be directly multiplied and it will be coming as 1.8 and I will be adding them, okay. This same way I will be like finding this x square, this is x square into y, okay. So the 1th index value of these, okay, these will be multiplied, I will be getting 1.8, okay. So this will be 1.8. So in the same way, this total values will be stored in their respective variables, okay. In the same way, for I equal to 2, all these values will be added. I equal to 4, all these value will be added. I equal to 5, all these value will be added. So after I equal to, you can say, sorry, I equal to, this will be 4. Okay. So after I equal to 4, this loop will be false. Okay. Because this loop will not run for I equal to 5 because n value is 5. So after this loop gets over, we will get the various values of x of x, x of y, and so on. So you can tell me that what will be the final value of s of x. So this will contain actually the summation of all these values. That is, it will contain 10. The same way, s of y will contain the summation of these values, 12.9. Okay. The same way, all the summation value will be stored inside all these variable after this loop gets over. Okay. So now, after we have got all the summation value, what is the next step? So the next step is, as we have seen in our working example, when we got these three equations earlier, then we put all the summation value that we have just got. Okay. And after that, we solve these three equations to find the values of the A, B, and C. Okay. So here I will use the Gauss elimination method to find the values of the A, B, and C. Okay. So if you have seen my Gauss elimination video, in which I have discussed that how Gauss elimination method can be used to find the solutions of the simultaneous linear equation. So these are actually three simultaneous linear equations, and the Gauss elimination method says that we have to first convert these three equations into the augmented matrix, and after that we will convert this augmented matrix into the upper triangular matrix, and after that we will apply the back substitution method to find the value of A, B, and C. So in that video, I have fully explained that how we can apply this Gauss elimination method with the help of working example, with the help of a C program, with Pseudo Code, and so on. Okay. So if you have not seen that video, I would recommend that please watch that video so that you get a full understanding of the Gauss elimination method. Because in this question, the main thing is how we can solve these three equations. Okay. So if you have not seen that video, please watch that video. You can find that video under the numerical method playlist, and the link of the numerical method playlist you can see in the description below of this video, or you can see the I button also. So now first we have to convert these three equations into the augmented matrix. So augmented matrix means it is the actually the collection of the coefficients. So these are the coefficient of A, B, and C. Okay, 30, B, C. So 30, 10, and 5. So 30, 10, 5. And this is the constant, that is 12.9. Okay. So on, I put all the constant value inside this matrix. So I created this augmented matrix. Now how I will actually create this augmented matrix in our code? So as you can see, I have taken a matrix having the name augmented matrix. And what will be the size of this augmented matrix? So as you can see here, we are having three equations. So in the augmented matrix, we are having how many rows? 3 rows. And how many columns? Total 4 columns, because the fourth column will be like this one. Okay. So the size of this augmented matrix is 3, 4. This position is 0, 0. This is 0, 1. This is 0, 2, 0, 3. In the same way, this position is 1, 0, 1, 1, 1, 2. Okay. And 1, 3, and so on. Okay. So what I will do, these values are actually the summation values. Okay. These 30, 10, 5. Okay. Or this value specifically is the n value, and these are like this value, or you can say this y, xy, and x square y. Okay, these all values. So actually these are the summation values only, right? So what I will do, I will place all these summation values inside each of the element inside this augmented matrix. Okay, so I say that at 0, 0, please put x of x2. Okay, so s of x2 was actually 30. Okay, the same way at 0, 1 position, this one, please put the value of s of x. Okay, so s of x was actually this 10. So 10 means actually this summation of x. Here also you can see this summation of x was saved inside this s of x. Okay, so in this way I have put all the summation value at the various places, and this was just n. Okay, so this 5 was n, so I have just put at 0, 2 position the value of n. Okay, so this way I have created the augmented matrix, right? Now after getting this augmented matrix, what is the next step? I have to convert this matrix into the upper triangular matrix according to the Gauss elimination method. Okay, so what is the upper triangular matrix? As you know, upper triangular matrix is the all the elements below the primary diagonal will be 0. Okay, so you have to take care that when I am saying that you have to convert this augmented matrix to the upper triangular matrix, so actually we will be just taking this part only. We have to convert this part to the upper triangular matrix, not this part. Okay, so we have to take only this much part, and this is the primary diagonal, right? So these three elements should be made 0. Okay, then my matrix will be converted to the upper triangular matrix. Okay, so for that, what I have to do, so if you have seen my Gauss elimination video, in that video I have discussed this method in a very deep way, so you can check that video. And in this video actually I will not be covering all the things of the Gauss elimination video in a very deep way, so I will be just taking the code from that video only. Okay, so this code is actually the same code that I have discussed in that video, so please watch that video to get the full coverage of this method. The Gauss elimination method converts this matrix to the upper triangular matrix using the row operations. Okay, so what I will do, I will actually convert this 100 to 0 first. Okay, so for that I have to first find the ratio. Okay, so that this will become 100, and then I will say that R2 equal to R2 minus some ratio into R1. Okay, so here I have to find the ratio. So the ratio will actually be this 100 upon 3, because I am working on this row and this row. Okay, so I'm assuming this is the row number 1, this is the row number 2, and this is the row number 3. Okay, so this will actually be 3.33. Okay, so I will say R2 equal to R2 minus 3.33. Okay, so if I apply this row operation, I will be getting a new array. So this array or this matrix will be like this. So row 2 has become, this element has become 0, and the same thing has been applied on 30 and 10, this operation. So it has been converted to minus 3.33. Now again I will apply the row operation on this row. Okay, so actually what I have to do, say okay, change the R3. So R3 equal to R3 minus some value, okay, some ratio into of R1. Okay, so I will use these two array. Now what will be the ratio? So when I am dealing with this row number 3 and the row number 1, so ratio will be row 3 value upon this 30. Okay, so this will give me actually 11.8. so this will be 11.8. so this row transformation I will apply, and I will get a new matrix. So I will be getting this matrix. Okay, so my this element has become 0. Now again I will apply the next row operation. So as we have to convert this minus 18 to 0, so that my whole matrix has been converted into upper triangular matrix. So for converting this minus 18 to 0, I will take the help of this upper row, that is row number 2. Okay, so accordingly I will apply this row operation R3 equal to R3 minus row 2, but here I have to take the ratio. Okay, so ratio will be this minus 18 upon minus 3.33. so I will get the ratio as 5.405. Okay, so this will be 5.405 into of R2. So I will apply this row transformation on this row number 2 and row number 3. Okay, and finally I will get a new matrix. This is the new matrix that I have got. Okay, all these three elements are 0. That means my this part has been converted to the upper triangular matrix. So you can see this code is actually doing all these three things. Okay, so I have again explained this code in the Gauss elimination video. You can check that video. So just to tell you, this line is actually finding the ratio. Okay, and this loop is actually applying the row transformation. So this line is actually applying the row transformation how many times? So as you can see in this matrix, in each of the row, how many columns are there? There are total 4 columns. So I will be actually applying the particular row operation on the 4 columns of the each row. So this is saying that you have to run actually 4 times for this question, or 4 times, and you have to apply the row operations. Okay, so this is again and again applying the row operation. For example, first it is applying row operation on this, then this, then this, and then this. Okay, and after that is over, then again it is going, and again it is coming inside, again finding the ratio, and again applying the this row transformation. Okay, so you can check the video on the Gauss elimination to get a in-depth coverage of this code. Okay, now after finding the upper triangular matrix, what is the next step? So I have to find the value of A, B, C. So for that I have to apply the back substitution method, and this is the code for that. Okay, so the Gauss elimination method says that now to apply the back substitution, you have to convert these three equations or these upper triangular matrix into these three equations. Okay, so these are the three equations. These are the coefficient of A, B, C, and this is the constant. So I have written 30A plus 10B 5C equal to 12.9, so on. And these are zeros. Here coefficient of A is 0, here A, and the coefficient of B is 0. So in the second equation, I have not written this 0 into A, okay, because this will be 0. The same way in the third equation, only coefficient of C is there, okay. So here we can see we can solve this third equation and we can easily get the value of the C, okay. So we are actually solving these three equations in the reverse manner. First we will get C, then I will put C here and I will get B. And when I got B and C, I will put in the first equation to get A. So when I will solve in this way, I will get A, B, and C. Okay, so these are the same value that we have got in our working example. So how this code is actually implementing these all things. So again, I have explained this in our Gauss elimination video in depth. So you can check that video for the full explanation of this code. So here I will be telling just some hints. Okay, so this line is actually finding this value, that is C. Okay, first we have found the value of C, and inside this code, first I will get the value of B, then I will get the value of A. Okay, so now just to tell you, here I have not taken the variables A, B, and C. Here what I have done, I have taken a value array. Okay, so there will be a array value, okay, having the index 0, 1, and this will be 2. Okay, so you can take the maximum size of this array as 3 because I have to find the value of the 3 unknown. So here I will store the value of A, here B, and here C. Okay, so here you can see the value of n minus 1. So in this question, actually you have to understand that this n is not the number of observation. Okay, so this function is actually using this n variable, but this is not number of observation. Here this n mean the number of equations. Okay, the number of equation that we are solving. Okay, right? So you can see here I am first storing the value of the value n minus 1. So value n minus 1 means value of 3 minus 1, that is value of 2. So here I will store the value of C. So this line is storing that value. So how it is doing? So it is just saying that in the code we will be having this augmented matrix, okay, or you can say upper triangular matrix. I will not be having this, right? So using this I will be solving to find the value of C. So the C value, as you can see, it is this divided by 7. So that means this divided by 7. So I can simply say this will be actually 9.94, as you can map this from this matrix, and this A of n minus 1 will actually be this 7. Okay, so here I have taken the name of the augmented matrix as A. This function is taking the name of the augmented matrix as A. So this matrix is actually the name A. Okay, so after we have got this C value from here and we have stored, now in this code we will be finding the value of A and B. Okay, so I will actually recommend you to see the video of the Gauss elimination because this video will become lengthy if I explain this whole code again. Okay, so just to tell you, this line is actually first storing the value of, you can say, 1, that is B, and after that in the next iteration it will store the value of 0, that is A. Okay, so this was our Gauss elimination method and we got our A, B, and C. So what is the next step? So next step is we have to just put these three values in our parabola equation. Okay, so parabola equation was ax square bx plus c that we have assumed. So we can simply put A, B, and C in this equation, or we can just print in our C code so that we can print these equations. Okay, so main thing was we have to find the value of A, B, and C. Okay, that we have achieved. So now I hope that you have got the understanding of the pseudocode, and if you have not understood some of the part, then you can please rewind this video and you can check that again. So now let's see the C program for this method. So this is the C program for the implementation of this method. So if we start from the main function first, then we can see we have this main function and we have taken the various variables, right? And this is the value array that we were using in our Gauss elimination method. Okay, so you can see here, first we have taken the number of observation or number of data points that we want to enter, and after that I have created the X and Y array according to this n size, okay, and the augmented matrix is there. Now the X and the Y values I have taken from the user, right? And after that I have found the values of the various summation, okay, and after that I have created the augmented matrix, okay, the same code that we have just seen, okay. Now after that what I have to do, I have to convert my augmented matrix to the upper triangular matrix, okay, and after that I have to solve using the back substitution method, that upper triangular matrix, to find the value of the A, B and C, right? And after we have got the value of A, B and C, I have just printed the value of A, B and C, which were actually stored inside the value array, okay. And finally I have printed the equation of the line using those A, B and C, okay. So I have created two functions actually, convert to upper triangular matrix and apply back substitution, okay. So this convert to upper triangular, this function will actually be converting my augmented matrix to the upper triangular matrix. So two arguments are given to us, augmented matrix and this 3, okay. So 3 is like number of equations or the number of rows in the augmented matrix. So these are actually 3 in our question, okay. So we can see the code. So here is the code. They convert to upper triangle, okay. So this is the augmented matrix A, and this n is having the number of rows in this matrix. So this is the same code, okay. So this code is actually I have explained in the Gauss elimination video, okay. The same code is there, okay. And inside this code I have printed the intermediate forms that we will be getting while we will be converting our matrix into the upper triangular, okay. So after that this back substitution method is there, okay. So this is the same code that we have seen just now, okay. Now after these two functions are over, now here you can see I have taken the value array, right? So the value of A, B and C will be stored inside this value array. So all the changes that we will do in this value array, they will be reflected into the main function, because main function is having this array actually, okay. So inside the main function, here you can see I am using that value array, okay. So value of 0 will be having the value of A, value of 1 will be having the value of B, and value of 2 will be having the value of C, okay. Now I have just printed the equation of the line. So here you can see this is like x square, okay. It is taking the value of A, so it will be like A of x square, then plus it will be B of x, okay. This will be B of x. So percentile 0.2f, this is fetching the value of value 1, that is B, okay. And this is plus, this is the value of 2, that is C value, okay. So this percentile 0.2 means that I am taking just the 2 value after the decimal places, right? So let's run this code and see what is the output. So let me enter number of observation as 5, then the value of x are 0, 1 to 4. Now let's enter the value of y that we have seen in our working example. Now after entering the value of y, you can see that we have at last got the equation of the line, and before that you can see the value of A, B and C are these values, okay. So these are the same value that we have seen in our working example, right? And before that, as you can see that after entering the value of y, we have applied the Gauss elimination method to find the value of A, B, C. So these are actually the intermediate forms of that method. So it is up to you want to print these forms or not, okay. So this is the ratio, then intermediate form, again the ratio, then the form, okay. So there are 3 intermediate forms, and after that we have got the value of A, B, C, and then we have printed the equation of the line, okay. So this is actually not the line, this is actually the parabola, okay. So this was just a small mistake, okay. So I hope you have understood this code, and if you have any question, comment, suggestion, please write down into the comment box and I will answer them. Please do subscribe this channel and press the bell icon for further notification. You can watch the other videos on the numerical method into the numerical method playlist. You can find the link in the description below. So do like and share this video among your friends. See you in the next video. Till then, goodbye.